Okay, factoring. Back at it. So, reminder, when you are factoring, every single question, is there something in common? If there is, that's what you need to go after first. You're like, okay, I think there is. Well, I see X's, there might be a number. So if I think so, what do I want to keep track of again? So when I'm looking at these, I'm always looking for the biggest number that divides into all terms. So I look at 2 and 18. I think 2 is as big as it's going to get. If I wasn't sure, I can divide with my calculator. I can use the chart on the back and find 2 and 18 in a column. All those things would work. Then I look for the smallest exponent if all my terms even bother having one. So here I'm like, okay, they both have x. This one, 2 is smaller than 5. So I'm going to take out x squared. Once those are out, all I'm basically doing is dividing that through to each of these. So I'm like, okay, 2 divided by 2 is 1. What do we do with exponents when you're dividing? Subtract. So 5 minus 2 is 3. And that's all I'm going to do to each of these terms. 18 divided by 2. 2 minus 2 is 0. So if it's x to the 0, I just don't put any x's anymore. And that one, ladies and gentlemen, is done. So sometimes all you're going to be able to do is factor out a common factor and you're going to be done. Other times, you may look at one like this, you're like, okay, wait a minute. Can I take out an x? No, this doesn't have x. Well, I can divide each of those by 2, but I can't divide, 1 by 2. So I don't have anything in common this time. Once I've gone through that part, thank you. Once I get through that, I'm like, okay. So now you're like, oh, is this a diamond? It is. So reminder on diamonds, we multiply to get the number on the end. We add to get the number in the middle. And the same two numbers got to hook us up for both of those. And as we've talked about many a times with this, there's clues everywhere. That minus there, the only way I can multiply to get a negative is one positive and one negative. And so now I'm like, okay, I need two numbers that multiply to 24, but they're 2 apart because the signs are different. So what multiplies to 24 and are 2 apart? 6 and 4. Now, which one's the 6 and which one's the 4? That's right. That is always going to be the sign of the bigger number. And that's it. If the whole part of here is, well, I can figure out the multiply, but trying to figure out the add thing and stuff is tricky, again, look at that chart on the back, and any place that you're finding 24s, follow them to the two sides and kind of work it through. Okay? Oh, 6 and 4, they're 2 apart, and we got to work at it that way. So it just constantly is going to become, can I take something out in common? Maybe. You're like, I don't think 50, I don't think 8. Ooh, that's bright, isn't it? Let's tone that down a little bit. Okay, so that didn't go in evenly, but it doesn't mean nothing does. So even if you're like, well, let's see. 4 goes into 8, no. 2, 2, okay. So I can get out a 2. Not an x. They both do not have x. So I'm just going to divide each of these by 2. Now, that, bless you, is a good start. Like, wait, a start? Yeah. Because the other part of this that I have to keep straight is when I've only got 2 terms, there's a distinct possibility that this could be a difference of squares. Again, how do I know? Well, if I'm not sure, if both numbers I see here are in the list, oh, they are. Hopefully you remember from when we did this before, if I need a little reminder, that we said, okay, to get 4 I need 2, can't forget my x, and 25 would be 5. Just the numbers. Signs I'm not worried about because this is going to tell me what signs to use. This is my A and B. And so I get here A plus B, A minus B. And I'm set. So again, everything that you need is going to be there for the help on the sheet if you give yourself the chance to work it through. So you're like, okay, so far we've seen I can just factor something out. That's it. We've seen a diamond where nothing factored out. We've seen factoring out and factoring what's left inside, possibility. What if it's none of those? I'm like, well, that's only a 1, so I can't divide anything in. This doesn't have x. So you're like, okay, well, now what happens? This is not a multiply and add problem because there's a number in front. This would be a, for most of you, some of you do guess and check. For most of you, this is a slide and divide special. So reminder of a slide and divide. Slide or multiply that 6 down to the end. And now we're back in the same situation that we were up here. Now we're doing the multiply and add bit. We talked about using the chart. If you're like, nah, I don't know about the chart, you can just start dividing numbers into 72 until you find a pair that's 1 apart. I'm kind of at small numbers here. But if I keep going, sometimes I'm going to get decimals. And finally, there we go. 8 and 9 are 1 apart. It's a negative multiply number again, so it's 1 of each sign, but that's the sign of the bigger number. But be careful. You've done the slide part, but you're not done. That 6 that was here before, we have to do divide part. And if it doesn't go in nice, 6 doesn't go into 8 nice, it's not clean. Math, enter, enter. We're still going to reduce the fraction if we can. We'll do the same thing with 9 divided by 6. It doesn't come out nice, but it does reduce. And if there's still fractions at the end, and in this case that's both of our values, that denominator moves back to the front, in front of the x. So the 3 moves in front of the x, the 2 moves in front of the x. and I'm done. Sure. So why am I not stopping here? Okay, if I stopped there and I went ahead, the question was, why didn't I stop here? Because we did up there. If I were to multiply this back out, and put everything back together, is that my original problem? No. But, so that's reason number one, it doesn't work. Reason number two, if I multiply this back out, and it's always a way you can check your answer if you're not sure. If I do my first, 3 times 2 would be 6x squared. Outer. Inner. And last. And combine my terms in the middle, and there is my original problem. Anytime you factor, if you take your answer and you multiply it back out, you should get the original problem back. Anytime there's a number in front, you're never going to just have, because this is even like 1x times 1x isn't 6x squared. That's the one part we got to think about with these as we're working through them. But again, after a little bit of practice, we'll get back there. Now, I want to keep mixing it up a little because I know it's a Monday and I'm not going to be able to keep your all's attention forever. So, number 6. Again, you're thinking, oh, slide and divide. Wait a minute. Before you do that, could I get to the answer for that? Yes, but I could make it easier. If something divides into all 3 of these, and it does, we're going to divide all of those by 2. And in this case, what's nice about doing that is, by taking the 2 out, by dividing it out, what's left is just like what we did in number 2. Like that 2 is going to stay out there, but this, now that it's just x squared, is a multiply and add. That only works when there's no number in front of it. So here, multiply is positive. It could be 2 positives. It also could be 2 negatives. That sign will tell me. So since the signs are the same, now let's see. Can I do any more with this? You're like, hey, Hardy, 5 and 2, they're 3 apart, which is true. But here's the problem. Sure. If I use 5 and 2, let's check this out. If that was 5 and that was 2, negative 5 and negative 2. Hardy, that's negative 7. But the signs have to be the same. What the heck? Sometimes, if you try the parts and it doesn't work, you might just be able to take out the 2, but you're not going to know until you try it. That's why I wanted you to see this. Because I didn't know that it wasn't going to work until I got into it. That doesn't happen often, but it does happen. We just saw it happen. And then the last one, and we touched all the bases again. You're like, wait a minute. Nothing divides in, but I've seen those numbers somewhere before. 8 and 125, they're perfect cubes. So again, if you're rebuilding your new one here, we're going to do this kind of like we did number 3. We're like, okay, 8, the cube root is 2. Don't lose your x. 125, your cube root is 5. And since this is cubes, plus in the middle, sum, plus, I'm just following this. And again, if you want to label them with a little a and a little b, so you're literally just plugging them in, There's nothing wrong with that. So a plus b, 2x plus 5. Square your a term, which means you're going to square the 2 and the x. Okay, don't just square the x. Minus a times b plus your b term squared. Nice thing about sum and difference of cubes, once you plug it into the form, it's done. You're not going, do I still have to factor something? Do I still have to do something? Whatever that happens to be. One last one going with that. We literally will have seen everything you could run into. Now you look at this last one, like, ooh, Hardy, cubes, gotcha, cubes. And you're like, wait a minute, though. 2 and 54 aren't in the list. Which is true, because I decided for some reason, oh yeah, I still have to look at this, even if there's only 2 terms. Does something divide in? I think it does. 2 does. So if I divide out a 2, so take the 2 away from the first one, 54 divided by 2 is 27. Now let's look again. Okay, well, x cubed, you're like, okay, I can handle that. That's just x, I gotcha. 27 is 3. Now I'm going to do something similar to what I did over here. That 2 is still there. And this time, though, more folding for Hardy to do, just a sec here. This time, we have a difference of cubes because minus is in the middle. So I'm going to follow this pattern. There's my A, there's my B. So A minus B. Square my A term, which would be x squared, plus multiply these together, plus my b term squared. So I'm squaring 3, which is 9. That 2 again has got to be in the front. Can this drive you crazy at times? Yes. Okay. Can it be frustrating? Agreed, it can be. But again, we've got to get that practice in. So let's do this. I don't want to drive you completely crazy. You're like, well, this is a way too Hardy. Oh my gosh, 18 problems, you're out of your mind. I agree, that would be out of my mind. So let's go for evens. I do have evens and odds done though. So like if you accidentally did one or the other, you can still check. But again, this is the time where some of you have got to press. I will say this off once I hit